those two. All right, let's continue then. We actually, this may be the last day for us to talk about ranked voting systems. I hope that you feel that it's been interesting. Remember, my I don't especially care if you're interested in politics or not, but what I like to include in this class are topics which are mathematically interesting, even though they seem simple on the surface. When you try to really think more about it, they turn out to be a lot more complicated than you thought. And I think that voting is in that category. I hope that I have at least been able to convince you all of that. Anyway, I would like to talk about one, perhaps two more real quick methods of voting that actually don't fit precisely into the same category as the ones that we've been talking about so far. So this first one, this is sort of like for all the democracy haters out there. There are actually some situations when voting kind of produces bad results. And here I would like to describe one. So let me just say, sometimes voting gives kind of bad results, like no matter how you do it. Even if you only have like two options, if there are only two options, then there's not really any fancier way to do voting. Everybody just chooses their favorite of the two options, and you see who got more choices. But even that sometimes gives bad results. Here is a scenario. Let's say this is a made-up little story. Each night my two roommates and I are going to choose where to go for dinner. And we figure let's just like have a little vote about it every night. All right, we can do that. And let's say I like Chinese food, and they both like McDonald's. And we're going to vote on this every night. This is a scenario in which I would say voting kind of gives bad results. Anybody agree? What's wrong with this scenario if we just decide we're going to vote every night, the three of us? Yeah?
Because you're the only one that likes Chinese food.
Right. Yeah, I'm the only one that likes Chinese food. And so every time we vote on this, the McDonald's will win. And this will result in us always having McDonald's and never the Chinese. And this is, in my opinion, kind of unfair. Now, it is true that I lose the vote every night. And so, I mean, from that point of view, it's not fair to let me win because there's only one of me versus two of them. But there's somehow, like, it also seems unfair to me that, like, there's three of us. Shouldn't I get my way, like, about 1/3 of the time? But instead, if you vote every time, I get my way 0 of the time, right? They win all the time, and I lose all the time. So the problem here is, if we just vote every night, so voting in the usual way, at least, voting every night is, I'll put in quotes, unfair. I mean, it is true they're going to win fairly every night. I'm not saying they're cheating or anything like that. But voting every night is unfair because I never get my way, and they always win, right? I never win, and they always win. But I feel like since there's three of us, I should get my way every so often, right? Maybe not most of the time because there's more of them, but at least I should get my way sometimes, right? But if you just straight up vote every time, I never get my way. All right. There's actually a name for this in sort of like political science. People talk about this, and even the founders of the United States, who were kind of like, they saw themselves as kind of pioneers of a new type of society where everything was based on votes and democracy. They also thought about this. So there's a name for this. This is called, anyone know the name for this? The phenomenon whereby if you vote on stuff, it means that the people who are able to win the votes get their way every time, and the people who lose the votes, they don't ever get their way. And there's somehow this is a little unbalanced. Anybody heard this before? This is referred to as the tyranny of the majority. The tyranny of the majority, all right? And this is a basic feature of voting that's kind of unavoidable. Like, as I've said many times in the past, I do believe in democracy, and I think voting is the correct way to organize a society, but it's not perfect. And this is one of the major problems with voting on everything. The tyranny of the majority. You could say this in like a more extreme way. Sorry. How about if, say, 51% of the people agree, they will get their way every time. They will get their way 100% of the time. And the other 49% will get their way none of the time. And this, to me, sounds unfair. They get their way 100% of the time, the other 49% never get their way, right? The tyranny of the majority, all right? If anybody in a just pure straight up democracy where everybody votes on anything, the majority turn into some kind of tyrants because they can call the shots all the time, and anybody who's not a majority will never be able to win any votes, and so they won't get their way. And there's something, in my opinion, undemocratic about this, something unfair about this. So the people who founded the United States actually were aware of this concern, and this is why they constructed our democracy in a fairly complicated way. Like, this is one of the reasons that people say that the Electoral College is a good idea. This is debatable whether it's a good idea. I kind of don't really like the Electoral College, but one reason that the Electoral College is sometimes described as positive is because we do not want to just straight up vote on who will be the president. Because if you just do a straight up vote of everybody votes and you count up all the votes and that's the winner, this could lead to a tyranny of the majority situation. And it would somehow be more fair if you counted the votes state by state and then added up the Electoral College points. I'm a little unconvinced by this argument, but this is the principal reason, or one of the major reasons, why we have like the president who does a bunch of stuff, but we also have the Senate and the Congress, and they and the House of Representatives, and they are elected in different ways. There's only 2 senators from each state. The representatives are proportional to the populations. All of this kind of like more complicated systems. The basic reason for a lot of them is to try to get around this tyranny of the majority issue. But anyway, this is a problem in all democracies, and it is something that is worth trying to address. So, our next voting system is meant to address this basic issue, all right? All the systems we talked about, the plurality, the Borda, the ranked choice, they all are kind of victims of this sort of a thing if you do traditional voting. Here is a system which totally destroys the tyranny of the majority. This sounds stupid, but you can tell this to your moms next time you talk to them. This is a voting system that sounds stupid on the face of it, but actually the more you think of it, you begin to think, actually that's not so stupid. Sounds stupid, but it's not. This is called, the name of this is called the random dictator method. It sounds extra stupid with that name. Whoever came up with this name was trying to make it sound stupid, I think. The random dictator method. What it means is, after everybody votes, so everybody votes in the normal way, all right? You could rank your choices, but actually the rankings don't matter in this method. So anyway, everybody votes as usual. But when you count up the votes, you don't actually count up all the votes. You can imagine doing this in real life. You put all the votes like in a bucket, and then somebody reaches their hand in the bucket and pulls out one vote, and whatever that one vote says, that's the winner. This is called the random dictator method. So everybody votes as usual, and then after the vote, one ballot is chosen at random. and then that ballot determines the winner. Whoever the top choice on that ballot is the winner. This is called the random dictator method. It's called random dictator. I mean random because you're making this random choice. Random dictator because you're pulling that one ballot out, and then that one ballot decides the winner all by itself. That's why it's called a random dictator. It is as if the ballot that you picked becomes a dictator. The difference with the ordinary dictator method is you don't decide ahead of time who the dictator is going to be. It could be any one of the ballots, and you choose it at random. All right. Can anybody say, how does this actually, I claim, this solves the problem of the tyranny of the majority? Like, for me, choosing the Chinese versus the McDonald's. Can anyone explain why is this better in that situation? I think it is much better in that situation than actually doing a vote where you count the votes up. No?
Because then, like, you vote on the better chance of winning because it's like random, so like it doesn't matter that it's two against one, since you're just picking like randoms.
Yeah, right. It means that it is possible for the minority to win. Like in this case where it's 2 against 1 with me and my roommates. If we're doing this every night, then about 1 out of 3 of the nights I'm going to get my way, and about 2 out of 3 of the nights they're going to get their way. And that actually is very fair. Like that's kind of how it should be in that kind of a situation, since there's 2 of them and 1 of me. Did you have a question?
Yeah, I just think, I don't know, I guess I was thinking about it from the standpoint of, well, if there's 2 votes in the hat that are the other option and there's only 1 of yours, like, don't they still have a better shot of winning?
Yeah, right. Yeah, they still have a better shot of winning, and I would say, to be fair, like they should have a better shot because there's 2 of them and only 1 of me. Yeah. So it all makes total sense. So this, like I said, it sounds crazy because you're making this kind of random choice. But if you think about this statistically in terms of probabilities, it actually is kind of like a perfect system. It works exactly the way you want. So I'm going to say it works so that if, let's say, X% of the people have some opinion, they get their way X% of the time. I'm saying X both times. Like if 1/3 of the people have the same a certain opinion, they're going to get their way 1/3 of the time. Or if 75% of the people feel a certain way, they will get their way 75% of the time. If you do this over and over again, of course. If you're only doing this once, then who knows? Like it's just like one time a random pick. That I would say is a little suspicious to sort of like I wouldn't want to choose the U.S. president in this way just because you're pulling once out. If it's like if your candidates are Trump, Biden, or Hitler, and there's only like one guy who voted for Hitler, but there's still a chance you're going to pick Hitler, and I would say we don't really want that. For such a high stakes thing. But I will say this is great. The probabilities work out great, and as you know, I'm sure, probabilities really become manifest if you're doing something over and over again. So I would say this system is great for repeated low stakes decisions. Right? Such as going to dinner every night. You're going to be doing this over and over again. So making each individual one depend on a random choice is not such a big deal because you're doing it over and over again. It'll even out in the long term. And I'd say repeated low stakes decisions. If you're doing something super important, I would hesitate before choosing the answer randomly. But if you're doing it over and over again and each individual one is not all that important, random choice is actually a really great system. All right? And it defeats the tyranny of the majority. So how would we do this in particular examples? So let's just talk about some particular examples. How about, I'm going to write down some votes like we usually do. let's say 30 people vote A, then B, then C. 40 people said C, B, A. 15 said B, A, and C. Another 15 said C. That's A and B. How about that? All right. And let's say we are going to choose the winner using the random dictator method. You'll notice, just for convenience, there are 100 total voters here. I did that so the numbers would work out nicely. What are the results if we use the random dictator method? Random dict. First of all, you can't say exactly what's going to happen because it's based on a random choice, right? Somebody's going to reach their hand into the bucket and just pull out one of these votes, and somebody will win based on whatever vote they pulled out of the hat, right? So we can't say exactly who's going to be the winner. It's based on a random choice, but we can say, sorry, my scribbler just stopped working. I just got a new one yesterday. They're killing me here. Any suggestions? I'm not sure what to do. Anybody have one of these I could borrow? Apple pencil or something? I see she's got one, but she shouldn't give hers to me. Can we take a little break? I have another one in my office, which is downstairs. Sorry for this. I don't know what to say. I'll have to. Oh yeah. Oh, okay. Is this an Apple or a knockoff? Nice. This is exactly the one.
You have to connect it, I think, through Bluetooth. Yeah.
It's a Bluetooth. No, I think it's working. Yeah. Oh, great. Thank you very much. You don't mind? Okay. Excellent. You want mine? My messed up one. Actually, could you try this on your iPad just to see if it's dead? All right. Okay. What happens if we use the random dictator? We cannot say with certainty because it's based on a random choice, but we can give probabilities. Like I can tell just by looking here. If I'm making this choice at random, A is more likely to win than B, just because I have 30 people who put A on top and only 15 people who put B on top. So A is more likely to win. How precisely can we give the probabilities? These are you have to do a little bit of math, I suppose. It's not all that difficult. Let's count up the total votes for A. How many people put A on top? Is just 30. So this is like 30 out of 100. So A's probability to win is 30%. All right? If you like, actually, can I write it this way? It's really 30 out of 100. As a fraction is 30 divided by 100. But that's 30%. I mean, everybody divided by 100 is easy. So this is 30%. All right, what about B? B, 15 people listed B on the top. So B's chances are 15 out of 100. So B's probability would be 15 out of 100, which is 15%. And then C, here's the tricky one. How many people put C on top? 55. Yeah, it's not really tricky, but you just have to notice. There are two different columns here with C on the top. That is a total of 55 people put C on the top. So this is 40 plus 15. That's the only thing that might be, something to consider. Otherwise, this is totally easy. So C's probability of winning is 55 out of 100, which is 55%. And that is the best you can do as far as the answer. If the question is, find the results using the random dictator method, you can't predict exactly what the result will be, but these are the probabilities of the various people going to win. So I would say, informally speaking, C is probably going to win, I guess, but A has some chance, and B has less chance than A, but also some chance that B could win. All right, great. Let's just try another one. Oh, here's a very, very simple one. How about me and my friends with the dinners and all that? If I were to list the votes for that, I have 2 votes for McDonald's and 1 vote for Chinese. All right? So how would I write out the probabilities? I mean, you can work all of this out in your head, but I would say the McDonald's gets 2 votes out of, you have to say 2 out of how many total voters? There's 3 in this case, so that's 2 out of 3. So their probability would be 2/3, which if you want to write that as a percent, it would be 66.6%, right? If I'm asking you to do this on a test, I would say just leave your answer as fractions, then, because you're not always going to be able to do those numbers on your calculator. All right, and then the Chinese would be 1 out of 3, which is 1/3, which is 33.3%. All right, if you did it right, these percentages should add up to 1, as they did in the previous one. Okay, so if you do the random dictator, my friends will get their way 2/3 of the time, I will get my way 1/3 of the time, which to me sounds perfectly fair. That's the way it ought to be in such a situation, right? Great, I got, oh yeah, one more, and then I have one for you all to try. This is not hard, you just have to sort of know where to write everything. So let's say 4 people said A, C, B, 3 said B, A, C, 1 said C, B, A, and 1 said B, C, A. Now the previous examples, I was trying to make the numbers come out nicely. This one, I did not try to make them come out nicely. So you have to just sort of work stuff out, and the numbers might be a little messy when you get there. So I would first of all decide what is the total number of voters, because that needs to become like the denominator of these fractions. So the total number of voters here, what do you say? 9, I think. Just add the numbers across the top. Looks like 9 to me. Total number of voters is 9. So that's going to be the denominator of the various fractions that I report at the end. How many votes for A? I see 4 votes for A. So A gets, their probability is 4 out of 9. 4/9 as a fraction. If this was on a test where you're not having a calculator, you would just leave your answer like that, but just for fun, you can plug this into your calculator. That's 44.4%. Dividing ninths, converting to decimals is always easy. All right, what about B? What do you say the fraction for B?
Same.
It's the same, yeah, also 4 out of 9, because we have 3 voters for B here and another 1 voter for B here, and so that is also 4 out of 9. Which is again 44.4%. And then the C, I see 1 vote for C. So C's probability is 1 out of 9, which is, I suppose, 11.1%. There you go. This is how we do it. Not, in my opinion, it's not difficult really. You just have to know where everything goes. I got one for you to try, and then we'll talk about something else. All right. Try them out. Give me the probabilities. You can just write them as fractions if you don't have a calculator. Whoa, my other one's working now. I don't know what happened. Can we talk about it? I would walk around, but this, if you know what you're doing, there's really not a whole lot to it. You should begin by finding the total number of voters. What did you get for that? 13. I think I agree with 13. There are 13 total voters here. And then we're going to add up the votes up top for all of these. I hope you agree with me now. I mentioned this once before. Actually, the rankings in this example they don't matter at all. All that matters is what's across the top, right? Because when you pull one of those random ballots out, you don't even look at the other two positions. So anyway, the A gets, how many total votes for A? I see 2 in the first column and then another 3 in the middle, so that's 5 for A. So A's probability is 5 out of 13. I put that in my calculator just for fun, 38.4%. All right, so that's the probability that A will win. B also has 5, I would say, right? 4 from the second column and then 1 from that other one down there. So B also has 5 out of 13. Same percentage, 38.4%. And then the C. It looks like only 3, right? I hope everybody agrees. This percentage I did on my calculator, 23.1%. So this is my answer. Really just that much if you don't have a calculator. All right, as usual, these percentages should add up to 100% if you did it right. Another way of saying that is these fractions should add up to 13 out of 13 if you did it right. And they do. The 5 and the 5 and the 3 makes 13. So that's a nice little way to check yourself before you wreck yourself. Any thoughts about that one? The random dictator is also a nice method to use if you're worried that there might be a tie when you count up all the votes. The random dictator method never results in a tie because you're just pulling one vote at random. And so even if the people like here there is a tie of probabilities, but that doesn't mean the result of the election is a tie. It just means A and B are equally likely to win when you're going to pull out one of the ballots at random. All right. The random dictator method. Sounds stupid, but it's actually, there are certain situations where this is actually really a very good method to use. Other situations where I would say it's a bad idea. All right. Okay, we got 20 minutes remaining. I think that's enough time to discuss one last voting system before we move on to something completely different. Maybe I will take this time to remind you of my big announcement from a few days ago. I'm not going to be here on Tuesday or Wednesday of next week, so we will have no class on Tuesday and Wednesday next week. I will come up with something for you all to do in the meantime. Look out in your emails for that, and we will reconvene a week from today. And on that day, we will not have our first test, which was originally scheduled then. It'll be the following week. Okay. One last thing, one last method. And this is also kind of an oddball method. The previous one was weird just because it's based on randomness, which is different from all of our other methods. This one is a little weird because actually this method is not based on rankings at all. Approval voting is what it's called. I personally am kind of an approval voting lover. I like approval voting. I have used it to make important decisions every so often. So, approval voting. Here's how it works. Voters don't rank their choices. They only say which options they approve of. Sorry for the preposition at the end of the sentence. They don't rank their choices. They just tell you which ones they like and which ones they don't like. I approve these ones. I do not approve these ones. So the typical ballot looks like if you were asked to vote in such an election, a ballot looks like, A, B, C, D, let's say. Your job as a voter is just to say which of these ones do you approve of and which ones do you not approve of. And maybe when you vote, you say, I like B and D, all right? You don't rank them. You don't say which one you like better. You just say, I like those two and I don't like the other two, all right? There's no ranking here. You're just saying who you like, all right? And then how do you decide the winner? You just add up all the check marks as usual, all right? That's how you decide the winner. So each of these little check marks is called an approval, and then to find the winner, you just count up all the approvals, and then whoever got the most wins. Whoever gets the most is the winner, all right? This is how approval voting works. If you're trying to explain this to somebody in very, very sort of simple terms, I would just say approval voting is just like ordinary voting, only you don't have to just choose one choice. You can vote for as many different choices as you like. That's how approval voting works. All right, so I will say this is like plurality. That is the normal system that we use in most of our elections, where you just have to choose your favorite. Only in the approval system, you don't just choose your favorite. You can choose as many as you like. So it's like plurality, but you can choose as many as you want to vote for. You can choose to vote for as many as you like. All right. Can I tell you a little story about approval voting? This is approval voting is near and dear to my heart because this is a little story about when I first came to Stag Country as a professor. We have faculty elections and faculty committees. Like there are committees of faculty that have to decide various things. Like for instance, you all have to do your core courses with the signature elements, like the writing and the social justice thing. And who decides which courses count as the writing or the whatever? There's actually a committee of faculty who look at the syllabus or whatever, and they decide. So there are these committees that decide everything. There's a committee about about athletics. There's a committee about the library. There's all kinds of committees. And we have elections to vote on who gets to be on these committees. And when I came here, my first year, we had our election. We had the elections at the end of the year. And it was like, let's elect a new person to be on the library committee. And there's maybe 10 different people on the ballot. And they said, we have one position open, so everybody just choose one of these 10 people. And I immediately said to my other math professor friend sitting next to me, this is a stupid system to use in this scenario because there are 10 choices and you're only going to let me choose one of them. And I don't even know these people. I know a few people who I know mostly the people in the math department. At least half of these 10 choices are people that I've never heard of. And everybody's going to vote choosing only one person. You're going to split everybody's votes like crazy because there are 10 options. I said to my friend next to me, we should use approval voting instead. And he said, what's that? And I said, that just means when you vote, you can vote for as many people as you want. You don't just have to choose one. Why is that better in this situation? It's because I don't hardly know any of these people, but maybe I know 3 of them, and I don't care that much about the library committee. Any 3 of these people would be good, but you're really gonna force me as a voter to choose one of them rather than the other 2? These are all unnecessary choices. It would be better if you could just choose to vote for as many as you like. And I sort of made this my own personal crusade. And about 3 years later, I managed to convince the university to change the way that we do voting. So now we do these elections using approval voting, and it's all because of me. This is my great accomplishment at the university. I'm not. In terms of sort of socializing, I don't get around all that much. I'm not. I don't know everybody all over campus is what I'm trying to say. But the people on campus who know me if you talk to like your, I don't know, your history professor, and you mention my name, they will probably say, I don't know who that is. You can say, oh, he's the approval voting guy. Like, oh, that guy, okay. This was sort of like my thing that I was into in public. Anyway, approval voting in certain situations is actually a great way to do it. It's very simple. So like some people in the faculty said, why don't we use ranked choice voting? And my answer was, because it's kind of complicated and you don't want to have to explain that to everybody. And also, ranked choice voting still makes me as a voter rank the choices. If I'm presented with 10 options and I don't really care all that much, you're really going to make me rank those 10 people. I don't even know half of them. And the other half, I think they would all be just fine. Ranked, in my opinion, in that situation, ranked choice is just too complicated. This is a lot simpler. So anyway, here is a typical example. These examples of approval voting will look very different from the ranked choice or from the other ranked methods because they're not rankings. A typical election, I would summarize if I were doing the numbers. No. I would summarize like this. Let's say 23 people vote. Now, this will look different. Let's say 23 people checked off A and B. All right? That's what this means. There were 23 voters who checked off A and B and not the other two. Let's say there are 37 voters who checked off A and D. 4 voters who just checked C. You can vote for only one if you want. 17 voters who said A and C. 21 voters who said B and D. 3 voters who checked off everybody. Is that allowed? Yeah, that's allowed. If you like them all, vote for them all. What do I care, right? Actually, if you think about it, voting for everybody kind of doesn't do anything. Like, you're just increasing everybody's total by 1, which really has no contribution to who's going to win or lose. You're just saying, I like them all. 5 people vote for nobody. You can do that too. Again, this has no impact on the result of the election if there are people voting for nobody, but it is allowed. You can just check off none of them. All right, and then 7 people vote only for B. Okay, this is what a typical approval election will look like, and then we, who's the winner here? So we just count up the votes for each one. So A gets... Basically, I'm going to look across the top row there, across where A gets the checks, and add those numbers. So A gets 23 votes in the first column, 37 from the second column. They did not get a vote from those 4 people, but they did from the 17, and they did from the 3. And then we would add these numbers together. When I added these up, I got 80. Right? So A gets 80 votes, 80 approvals, and so on, right? This is, again, not hard to do. It's just, you got to know how to do it. So the B gets a 23, and then a 21, and a 3, and a 7, I think. I'm reading across the row for B, adding the appropriate numbers where the check marks are. This one I added up before, and I get 54. Right? I hope everybody sees what I'm doing. It's pretty straightforward. The C, there are 3 places where there's a check. There's a 4, a 17, and a 3. So this is 4 plus 17 plus 3, which is 24. And then the D gets 37, 21, and 3, which is 61. And so A wins. A is the winner. All right? That's how we do approval voting. I don't think we really need to say, I don't think we need to do another example. I mean, there's not much to it. What's good about approval voting? I would say principally what's good about it is approval voting avoids what they call vote splitting. Vote splitting is when there's 2 candidates on the ballot who are very similar, and that results in about half of the people go with this one, and the other half of the people go with this one, and their numbers are artificially lower. vote splitting is when, this is what happens like if you have two people from the same party on the same ballot. If you're using the plurality system, this is a huge disadvantage for those two people. Approval voting avoids vote splitting. For example, if we have, let's say, two Republicans on the same ballot, two Repubs in the same ballot. Using the plurality system, this is a huge disadvantage for them. If you have, say, two Republicans versus one Democrat, the two Republicans will split the votes of the Republicans, and the Democrat, who is unsplit, will end up artificially seeming much stronger just because you forced the people to vote for one or the other of the two Republicans. If we have two Republicans in the same ballot against one Democrat, using the plurality system, the Republican votes get split, and the Democrat will have a much easier time winning because they're only, the Republicans are essentially only going to be counting half of the votes that are cast for them. So using plurality, the Republican votes get split, so the D has a big advantage. Using approval, this just doesn't happen anymore, because if you're using approval, you don't have to choose between one or the other Republican. If you're a hardcore Republican, you just check off both Republicans and your vote counts for both of them, right? So there is no such thing as vote splitting in an approval election, because you're allowed to just vote for both people if you really wanted to support both of them. So I will say, using approval, the Republican voters can just vote for both. So no vote splitting. Right? Exclamation, I'll say. Another great thing about approval voting, which is actually why I wanted to use it here at Fairfield, is because it's very easy to explain to people. There's no complicated system where people don't fully understand. I think ranked choice voting is not all that complicated, but if you're in a room full of people who have never heard of it before and you try to explain to them in 30 seconds how it works, they're not going to understand you. Approval, everybody will understand you right away. You just say, you can vote for as many people as you want, instead of just voting for one. And they'll say, oh, all right. That's how it works. Very simple. Here's something, I mentioned this to somebody as I was trying to convince, I had to talk to a lot of people to convince them to change the system here. And one person said, that's the stupidest thing I've ever heard of. I said, I don't think it is. What sounds stupid about it? She said, there's no way, you can't let some people vote twice while other people are only voting once. If you leave it up to each person to decide how many votes they're going to check. Isn't that unfair? She said you can't have some people voting twice while other people are voting once. That's not fair, because everybody's supposed to have the same voice, you know? I said, I disagree, Sue. Anybody agree or disagree? I disagree with this sentiment. What would you say?
I disagree because you can it was your choice to you could have voted for other people, but you just chose to vote for one person.
Yeah, right. It is a fact that some people are only voting for one person while some other people are voting for two people. But it's your own choice as a voter how many people you want to vote for. And someone who's voting for two people, it's not like their vote is counted as twice as powerful. It's not like they put a check mark and I count their vote as a 2. I count it as a 1, just for one person and also for another person. So it's a little counterintuitive. Some people, it is slightly confusing to some people, but I had to say to Sue, I didn't make this up myself. This is a real system that is used all the time. Actually, the approval voting is what they use when they elect the Pope. They do this ballot system, but every time they vote, they are allowed to choose several people. So, if it's good enough for the Pope, it's good enough for Sue. All right, I think that'll do for now. So look out. I will be sending an email about what I expect you to do while I'm gone.